You've seen it in the movies. A crew of astronauts takes a quick trip near a black hole, and by the time they get back, decades have vanished on Earth. In Interstellar, a single hour on that terrifying water world cost them 7 years. So, what about the mind-bending idea that 1 minute for you could equal 100 years for everyone else? Is that just Hollywood, or is it real physics? Let's ditch the fiction and run the actual numbers using Einstein's equations to see what's what. To even ask this question, we have to thank Albert Einstein. His theory of general relativity sounds intimidating, but the core idea is surprisingly simple. Turns out, gravity isn't some mysterious force pulling you down. It's a curve in the fabric of the universe, a 4-dimensional reality we call spacetime. Picture spacetime as a giant, stretched-out trampoline. If you put a bowling ball in the middle, the fabric sinks and warps. That's exactly what massive objects like planets and stars do to spacetime. A black hole? That's like putting a cannonball with nearly infinite mass on the trampoline. It creates a ridiculously deep well. Here's the kicker. According to Einstein, the deeper you go into one of these gravity wells, the slower time literally passes for you compared to someone far away. This isn't a feeling, it's a physical reality. Your watch, your heartbeat, your very experience of time slows down. This effect has a name: gravitational time dilation. So, how much can we slow down time? It all comes down to the black hole's mass and how close you dare to get to its edge, the point of no return known as the event horizon. As someone watches you get closer and closer to that edge, they'd see your clock tick slower and slower. The light from your ship would get redder and dimmer until you appeared to freeze in time, never quite crossing the line. But for you, time would feel perfectly normal as you fall in. So, what about that magic ratio? 1 minute for 100 years. Is it possible? Let's use a real-world example. Sagittarius A, the supermassive black hole at the heart of our own galaxy. It packs the mass of 4 million suns. If you hovered at a safe distance, let's say 10 times its radius, the effect is pretty underwhelming. 1 minute of your time would be just over 1 minute and 3 seconds back on Earth. To get a serious time warp, you need to get dangerously close. If you could park your ship just a hair's breadth outside the event horizon at 1001 times its radius, now we're talking. 1 minute for you would be about 53 minutes on Earth. That's a huge difference, but it's a long way from 100 years. This is where science fiction and science fact dramatically part ways. If you love having your mind rewired by the real laws of the universe, you know what to do. Subscribe and join us for more expeditions into the beautifully strange cosmos. So, could you ever hit that 1 minute to 100 year ratio? To get a time dilation that massive, where one of your minutes is over 52 million minutes for everyone else, you'd have to get mind-bogglingly close to the event horizon. The math shows you'd need to be at a distance of about 1, plus a decimal point followed by 19 zeros and an 18, away from the black hole's radius. That's a distance smaller than an atom. Trying to hold your position with that kind of precision is physically impossible. And there's an even bigger, gooier problem: tidal forces. Long before you got that close, the black hole's gravity would be pulling on your feet so much more strongly than your head that it would stretch you into a thin strand of atoms. It's a gruesome process with an equally gruesome name: spaghettification. So, the claim that 1 minute near a black hole equals 100 years on Earth is a fun but misleading exaggeration. While time dilation is very real, there's no fixed exchange rate. The wild effects in Interstellar were scientifically grounded, but required a gigantic, rapidly spinning black hole, precisely engineered for the movie's plot to make a planet with that kind of time warp even theoretically plausible. The universe doesn't need to exaggerate to be spectacular. The reality is that time isn't a constant tick-tock, it's fluid. It stretches and squeezes depending on gravity and how fast you're moving. For an observer actually falling into a black hole, their own time would feel totally normal, but in their final moments, as they cross the event horizon, they would witness the entire future of the external universe flash before their eyes. A black hole is where physics gets pushed to its absolute limits, where time itself seems to fracture. And while you can't realistically trade a minute for a century, the fact that time can be bent at all proves we live in a universe far stranger and more wonderful than any story we could invent.